In this video, I'll be going over Chapter 10, Exercise 10.3, Rectangle Class. Create class rectangle. The class has attributes length and width, each of which defaults to 1. It has read-only properties that calculate the perimeter and the area of the rectangle. It has properties for both length and width. The set accessors should verify that length and width are each floating point numbers greater than 0 and less than 20. Write an app to test class rectangle. So first, I want to look at what it means by floating point numbers. So if we go to Chapter 5, Section 5.10.3, it tells us a little bit about floating point numbers. It says, the average calculation is likely to produce a number with a decimal point. In other words, a real number or floating point number. The type int cannot represent such a number because type int means integer, and an integer does not include decimal values. So a floating point number includes decimal values. C# provides data types float and double to store floating point numbers in memory. The primary difference between these types is that double variables can typically store numbers with larger magnitude and finer detail. So basically it says to use floating point number or a real number with a decimal value, we need to use float or double. And if we look at Chapter 6, Section 6.6.3, it tells us just a little more. Sorry about that. It tells us just a little bit more here. It says, due to the imprecise nature of floating point numbers, type double is preferred over type float, because double variables can represent floating point numbers more precisely. For this reason, we use type double throughout the book, unless we're manipulating monetary amounts, in which case we use type decimal. So basically that says the exercises we'll be doing in this book for floating point numbers, we will be using type double. So let's go ahead and create our app. So we'll open up our Visual Studio and create a new app, a new C# console app. And then we'll start with our using directive, which will be using system. And then we will do the first part here in our instruction is create class rectangle. So because we want to be able to access this class outside of the class itself, we want to declare it public. So we'll go ahead and write public class, and then we know we're going to name it rectangle because that's what we were instructed to do. And then we'll add the curly braces, and anything within this class will go within these curly braces. And I'm just going to add a little comment here so that I know that this closing brace here is the end of the rectangle class. All right, so let's create class rectangle. Now it says the class has attributes length and width, each of which defaults to 1. So the attributes go within the rectangle class, and then the attributes are what we use inside the class that will describe the properties or characteristics and instances that belong to that specific class. So in this case, the attributes are going to be our instance variables, just like in our last exercise. So we'll say length and width attributes. In this case, they're also our instance variables. Okay, and then for our instance variables, or our attributes, we are going to declare them private. And that's because we don't want them to have invalid values. We want these hidden so that these variables can only be changed through the public properties that we're going to create later, where we can create validation checks. And then we'll use type double because, like we just learned, that's what we want for our floating point numbers. So we'll use private double, and then, sorry. So we'll use private double for length, and the same for width. Okay, so the class has attributes length and width, and then it says each of which defaults to 1. So so in order to set these attributes with a default value of 1, we need a constructor. So we'll create our, oops, oh my goodness. So we'll create our constructor. So we'll want to declare our constructor public because, again, we'll want to be able to access it with outside of this class. So we know we want it public, and then this will enable us to create instances from other classes or from the main method. That's why we want this to be public and these are private, because we don't want this changed without validation first. And the public means that we can access it from other parts and we can add validation later. Okay, so the default constructor is also public, and then the constructor is also a special type of method that's used to initialize an object's fields when it's created. So you can't just name the constructor anything you want. The name of the constructor must match the name of the class that it belongs to. This naming convention allows the programming language to distinguish it from other methods and recognize it as a constructor. So for this exercise, since the class is named rectangle, we'll also name our constructor rectangle. So it should say public rectangle, and then we still need our parentheses. Sorry. And that's because even though it's a special type of method, it's still a type of method and it can accept parameters. But for this exercise, we're not going to be using any parameters for this. So so we do need our curly braces. And then inside the curly braces, this is what we want our method to do. And what we want the method to do is set the initial values for the instance variables of this class. So again, length and width, those are the instance variables. So we're going to say, we're going to use our instance variable length, and we're going to assign it the value of 1. And we're going to do the same with width. Alright, so now the class has attributes length and width, each of which defaults to 1. So these are the default values here. Alright, so the next step is it has read-only properties that calculate the perimeter and area of the rectangle. So let's add this within the rectangle class, but outside of our constructor. We'll say it has read-only properties that calculate the perimeter and area of the rectangle. And the calculations for that are the area is length times width, and the perimeter is 2 times length plus width. So what we're going to do is let's take a look again at our book, and we'll look at chapter 5. And this will be section 5.7. So it says, a read-only property provides only a get accessor. This means that a read-only property does not change the value of a variable, it only retrieves or gets the value. So for a read-only property, we'll use the get accessor only. All right, so let's go back to our program, and we'll say okay, so we'll say we need a read only property for area, and we need the same read-only property for length, for perimeter. All right. All right, so for our area, we need to calculate the area by multiplying length times width. So we will declare them public because we do want to access them from outside the class. So we'll say public, and then we'll use double for, again, we learned that's what we're going to use for our floating point numbers. So public double area, and then we'll use our curly braces. And then all we're going to do is we're going to get, and so what we want to do is we want to return the value of length, which is the value of our our instance variables here. So we're going to return the value of length. That's all we're going to do for our read-only property. And we're going to do the same for the perimeter. And actually, no, for the area, we're going to be doing length times width. So what we're going to do is we're going to use our property for length, which we have not created yet. So we're not going to actually be using our attributes, because we are actually going to create a property. That way we can make sure that the values are valid before we assign it to our variables. So we're going to return length times width, and again, these will be our properties. And then for for perimeter, I have not changed that yet. So for perimeter, we're going to do 2 times length plus width. So we're going to return 2 times, length plus width. And we do want to make sure that these are capital, because again, these will be our properties. We haven't created them yet. That's why they're still underlined. All right, so now we have our read-only properties that calculate the perimeter and area of the rectangle. Now, let's move on to, it has properties for both length and width, and that's where that comes in, where I was talking about we haven't created these properties yet. Oops. We're going to, actually, okay, we're going to now create these properties. So, since they're not read-only, they'll have both getters and setters. So for length, so we'll create a property, public double length, and, oops, wow, public double width. Okay. And they will have a getter and a setter. Okay, so we'll say get, and then for our getter, this is where we want to return the value of length. And this will be, we will be returning the value that is actually assigned to the variable. So not capitalized. So this is, again, we're getting this value of the private field length, not right here where we're creating the property of length. We're getting the private field length, so it's not capital. All right, now what we want to do is we want the setter to assign the value that the user provides, or well, not that the user provides, but we'll assign the value that's so the new value, okay, so we'll assign the value of each new instance. So we'll say length, we're going to set length, we're going to assign it the value of value, which will be the value of the new instance given. So whether it's user input or it's just another, like a list of inputs, it's going to take that value and we're going to assign it now to our length instance variable here, our length field, okay? And then we're going to do the same for width. So we're going to say get, and we'll say return the value of our width field, and then set our width field, we'll assign our width field the value of the value given, or the value of the new instance, okay? Okay, so now the set accessor returns the current value of the private field of length and width. Or sorry, no, the getter returns the value of this private field width, and the setter assigns the provided value to the width field, okay? All right, so now we have our properties for length and width. Now, okay, it has properties for length and width. Okay, so now we'll move on to the next part where it says the set accessor should verify that length and width are each floating point numbers greater than 0 and less than 20. Oh, come on. Oh, jeez. Are you serious? Okay. So we are going to add that. So there's properties for both length and width, and then the set accessor should verify that length and width are each floating point numbers greater than 0 and less than 20. Okay. So that means we're going to be using our setters. So we still want to set the length field to the value given, but we want to first verify that they're floating point numbers greater than 0 and less than 20. So within our setters, we're going to add some validation logic. So before the value is assigned to the field, we want to check whether the value is within the given range. If the value is valid, then we'll assign the value to the field. If it's not valid, we'll throw an exception to catch the error. So what we'll do is we'll say, within our setters, we'll say if, and then we'll have our parentheses, and we'll say, let's see, oops, not that, okay. So we'll say if what is, oh my goodness, in the parentheses is true. So what do we want to be true? We want to say if the value given is greater than 0 and the value given is less than 20. So we want to say if this is true, so if the value is greater than 0 and the value is less than 20, we'll say then do what's in the parentheses. So we'll say then do this. Right, so if it's true, then do this, which is not that. But we will keep our, the same as we have here for width. We'll assign our length field we'll assign the value given to our length field. So only if this is valid, or only if this is true, only if this here is true, then we'll assign the value given to the length field. All right. Okay, all right, then we'll add if it's not true. So we'll say if it's true, do this. If it's not true, or else, do this. So say else, or, oh my goodness, why? So if what's in the parentheses is not true, so if what's in the parentheses is true, then do this. Else, if it is not true, then do this. Oh my goodness. Which we want to say, we're going to throw an exception. Okay. Else, if it is not true, then throw an exception. All right, so throw an exception. So for this exercise, because we go over this in chapter 10, we'll throw an exception of type argument out of range. And this will ensure that the invalid values are not assigned. So in chapter 10, section 10.2.1, it says it says throws an exception of type argument out of range exception, which notifies the client code that an invalid argument was passed to the method. And then it says you can use try catch to catch exceptions and attempt to recover them, and we'll go over that in a minute also. The throw statement creates a new object of type argument out of range exception. The parentheses following the class name indicate a call to the argument out of range exception constructor. After the accepted object is created, the throw statement immediately terminates in this case, the method set time, and the exception is returned to the code that attempted the set time, where it can be caught and dealt with. All right, so let's look at the figure. There we go. All right, so here is where they use the try catch statements, and they say try this, and then catch this. But how they, so here they're calling on that argument out of range exception. They're using that as a parameter, but how we use it here to throw, say, if it does this, then throw. So what we're doing is, if this is true, then we're going to set the value to length and width field. Otherwise, or if it's not true, else we are going to throw a new argument out of range exception, which is just this line right here. And that's exactly what we're going to do, is just add that one line right there. So we'll say throw new argument out of range exception, which is here. And then we want the parentheses. So again, throw new argument out of range exception, and we have the semicolon also. So we're saying if the value is greater than 0 and the value is less than 20, then do this. If it is not, then we're going to throw an exception. Let's put this back over here. All right. Alright, so now we'll do the same for width. So we have width here. We're going to keep the getter the same. And for the setter, I think this whole thing is a setter. We'll just change it to width. So width. So instead of assigning length, the length field, we're going to assign the value to the width field. Okay. Alright, so now we have our set accessors that verify the length and width are floating point numbers greater than 0 and less than 20. We also have our exception handling so that the program will not crash if the numbers given are invalid. So now we're going to go on to write an app to test class rectangle. So we are going to be doing this outside of the rectangle class. And we are going to call this, we'll say class, and let's just call it test rectangle. And of course we want our curly braces. Alright, so now we'll add our main method within the class because this is where we'll run our program. So we'll say static void main, and we'll take in our string. Wow. Oops. String. Okay. Alright, so there's our main method. Okay, so let's say end main method and end test rectangle class. Okay, so within our main method we are going to create a new instance of rectangle where we'll call the rectangle and we'll say lowercase rectangle to create a new instance of rectangle. Alright, so we're calling our rectangle class, and we're going to create a new variable called rectangle, that's a lowercase, and this variable will hold a new instance of rectangle. Okay, so this is how we are creating a new instance of rectangle. Okay. All right, now we want to display the results of that new instance. So let's first just display a rectangle. Oops. With the default values that are already given, and we'll check that those are that's working correctly. So if you remember, our default values we created up here, we gave them a default value of 1. So if we're going to create an instance of rectangle that is only using those default values, then what we need to do is just display the rectangle how it is now. So we'll add a console.writeLine so that we can display it to the console, and we'll have an interpolated string, so we want to use a $sign before our double quotes. So console.writeLine, oops, and then within it, we'll have a $sign and then our double quotes. And within our double quotes, we want the length displayed, and we want the width displayed, and we want the area, and the perimeter. Okay? Length, width, area, and perimeter. Alright, and now we're going to get the values for length, width, area, and perimeter by using our curly braces, and we want to write rectangle dot, but lowercase. So a lowercase rectangle dot, because this is saying we're going to take our new instance of rectangle here, and then we're going to display our length field. Well, we're actually going to display our length, the value that we get within our length property. So we are going to have the length capitalized, because again, we are getting the value we are getting the value of length from the length property, and we're going to do the same with width and area. So we'll say we'll take our new instance of rectangle dot width, and then the same with area, and the same with perimeter. Okay. So this is our interpolated string. Alright, now we can run our program just to see if it's getting and displaying the correct values, because we know our default values are 1. So let's just go ahead and run it, and we'll see if that's correct. And then we'll create a new instance with valid and invalid values. Alright, so you can see the length and width are given the values of 1, and then the area is 1 and perimeter is 4, so that's all correct. So that is great. Everything's working great. It's displaying right. I don't like how this, you have to kind of scroll over. So I'm going to go ahead and kind of break it here. And when I did that, it automatically added what it needs to add if it were 2 lines. So you can keep it the way it was and just scroll over. I just like to be able to not have it all the way over where I have to scroll over. Alright, so now let's display, So let's display a valid instance of rectangle. Okay, well, a valid instance, and then we'll display an invalid instance. And let's go ahead and say of length of width. That way we can check if it catches the error of if it catches any exceptions. If it throws any exceptions, we'll see it on the console and it'll display it as an error message. So, okay, so to display a valid instance. Alright, so in order to test the program with valid and invalid values, we're going to use try catch blocks. And that way it will ensure that the program doesn't crash when an exception is thrown. Instead, the error message is caught and displayed, allowing the program to continue running. So if we take a look at Chapter 8, it talks a little bit about these try and catch blocks, and it's section 8.5. So sections 8.5, 0.3, 0.4, and 0.5. So right here it says to handle an exception, place any code that might throw an exception in a try statement. So any of the code that might give an error, we're going to put in the try statement. And the try block contains the code that might throw an exception. The catch block contains the code that handles the exception if one occurs. So in their figure here, you can see in their catch block, they write a console.writeLine statement with a message that will display if it catches that exception. So what they're saying is in the try block is we're going to try this and check if it's valid, and then we're going to try to catch it if it's not, and if it's not valid, it will display this message. It says the catch block declares an exception parameters type. And here they say index out of range exception, but we're actually using argument out of range exception, and name EX. So so EX is the name that is commonly used for an exception. So the catch block can handle exceptions of the specified type. Inside the catch block, you can use a parameters identifier to interact with a caught exception object. So identifier and name, okay? So it says, when these lines catch the exception, the program displays a message indicating the problem that occurred. And then this uses the exception's built-in message property to get the error message and display it. So again, line 24 is what uses the exception object's built-in message, which is right here. The built-in message is console.writeLine ex.message. That's the built-in message that it will display. All right, so let's go back to our code now. So we know that we will be adding a try block. So let's say to display valid instance, we're going to be using a try block, and we're going to say try this, what's in the parentheses, and this is what we're going to say. We're going to create an instance, and then we're going to display it. So we're going to set a new instance of length and width, and this time we'll use valid values. So let's try rectangle. So again, our new instance of rectangle.length, and this is our property for length, and we're going to assign it the value of, let's just say 5. So again, we want these to be valid. Okay, and then we'll also do the width. We'll have that equal to some other valid number. Okay, and then we want to display it. So again, how to display the updated values, we're going to do the exact same thing. So we could create a method, and we can just call that method each time to be able to display the same thing every time, basically. We could use a method, but I'm just going to keep using this so that you can see how to do it for this exercise. It'll just take too long, I think. Okay. Sorry. Okay, so let's say updated values. So display valid instance, updated values for this valid instance, okay? So let's actually maybe we can do a little console dot write line, and we'll say something, we'll give it like a label. So we'll say valid instance. Okay. And again, this will just be kind of a label. And let's do a tab maybe, so then it'll say valid instance, and then this will, the results will kind of be tabbed over. And let's actually start this on a new line so that our new instances will be on a new line. So let's do the same here. We will do default values and tab this too. All right, then let's go ahead and check our valid instance here and see if it's going to display correctly to the console. Oh, well, I can't do that yet because I've only created a try block. We also need our catch. So we'll say, all right, so now we'll type catch, and then within our parentheses, we'll say, we're going to write our exception, which is, we'll write the exception parameters type, which will be argument out of range exception. All right, that's the type, and its name, which we're going to name EX, just because that's, you can name it whatever you want, but we're giving it the name of EX for an exception. That's just common practice, I guess. That's just good practice. All right, so if an argument out of range exception is thrown, then within the catch, so if an argument out of range exception is thrown, then we are going to, we want our program to catch it and then display an error message using the console.writeLine to display it. And then what we're going to have in there is, like we saw in the book, we're going to write, actually we don't need parentheses. We don't need the parentheses for this. We're going to write EX, because that's the name that we just gave it. We're going to write EX dot message. And then this should display an error message if it is, if an exception is caught. And then, let's see. And, okay, why is this underlined? All right, let's run it and see what we get. All right, so now everything came up correctly. It says, here's our default values, and now here's our valid instance that we gave it. And now let's go ahead and create an invalid instance. And we'll do one for length and one for width. That way we're testing all of its values. And we'll see if it displays an exception message, an error message for that exception, I should say. Okay, so in invalid instance, let's just do this same try catch, but we'll just make it invalid. So let's do 50. So create an instance, and then we'll say throw error, and then everything else remains the same. So let's go ahead and do the same for the width. And let's change the width to a negative value. So this should throw an exception. Throw exception, error message, I should say. So throw an exception, display error message. All right, so now we have, oops, and this will be invalid length, and this will be invalid width, because remember it should be between 0 and 20, and this is over 20, and this is negative, so they both should throw an error message. So let's go ahead and test that. Okay, so you can see for our invalid length and width instance, it gives the error message, specified argument was out of the range of valid values. All right, so for this exercise, that's really all you need. However, there are a few things that you could do. For instance, you could use, instead of creating instances here, you could enable user input, and I don't know. I'm not really going to go over how to do that and create the user input, but I can show you what it would look like. And the other thing you could do is within your here where you throw your exception, you could actually write you can also write your own like error message. So you could write something like let's see, so you could say, where am I at? Okay, so you could say within the parentheses here, you could add the name. So you could say name of, and this is length. So you could say name of length. And then you could say, let's see. Actually, let's just see what that does right now. Okay, so as you can see, by typing name of length, it gave the parameter of length, and you could do the same for width. So name of width. Okay. And then so you can see that also gave the parameter, which is length and width. That was the parameter. And then we can even go a little bit further, and we could say let's see, name of width plus, maybe plus let's call that again, name of width, oops, name of width, so So it's name of, and then you fill in this part. So that's width. Name of width must be greater than 0 and less than 20. My goodness. Why? Let's see. No. Oops. Yep. No. Okay. This is not supposed to be copied. Name of width. Okay, that's better. So now we can kind of see how that looks like. Alright, so there's no space here, but as you can see, it says parameter width, and then it would also say width must be greater than 0 and less than 20. So let's give this a new line. Okay, and then it says specified argument was out of the range of valid values. Parameter width must be greater than 0 and less than 20. And then we could even say enter, okay, new line, and we can say again name of width cannot have a value of value. So oops. There we go. So let's just put some, okay, name of width cannot have a value of value. Let's see how that looks. Okay, so specified argument is out of the range of valid values. Parameter width. Width must be greater than 0 and less than 20. Width cannot have a value of -3. So maybe I'll just add a thing there, but all right. Now I'm gonna go ahead and copy this, and I'll do the same for length. I'll just change. So again, when we had name of, now all we have to do is go in and change this to length. And it will also should give us the correct value for length. Now, of course, you don't have to do any of this. This is just kind of because we're just learning about this exception. What happened here? Oh, yeah, plus name of what? Oh, okay. Whoops. Plus, I forgot the plus. Alright, so now I should do the same for length. Yep, length cannot have a value of 50. Width cannot have a value of -3. Alright, so how that looks good. Now, I can show you really quickly. Let's see. Alright. Oh my goodness. Ah. Okay, well, I guess I won't do that. Alright, let's go back to... Alright. Now, the other thing we can do, like I said, is we could add user input. So this will enable you to test it out in the sorry, in the terminal, in the console for yourself. So first we would add a while loop. That way you can continue, the user can continue to add a value for length and width until it's a valid value. So we'll say we're going to create a variable to convert it to a string so that the program can read the user input, and then we're going to parse it not into a string. Nope. We're going to parse it into a double. That way we have our floating point number again, and then we're going to assign it, if we've parsed it correctly, then we'll assign it to the field, the length field. Else we will throw an error, and we'll say invalid input for length must be a numeric value, meaning that this wasn't able to convert it into a number. And we'll do the same with width. And then we will display the updated values and then exit the loop once they are correct and we can display them. Then we'll exit the loop. Okay, and then here's our message that we're going to display, and then that's to close it. So let's go ahead and run it like that. Oops, there are some errors, probably because I added it here. Okay. Those are actually there. All right, so let's try to run it. All right. Sorry. So we have all of our instances that we already created, and now we have our user input instance. So for length, let's say 3, that's valid, and for width, let's say -2. And then of course our error comes up. So let's try length. How about if we do 50 for length and our error comes up? How about 5 for length and 2 for width? And then it gives our length and width, area, perimeter, and then the program has ended successfully. All right, so again, you don't have to do all that. You can do it whichever way that you prefer. I hope this helped. I know it took really long. It really shouldn't, it does not need to be there. It really shouldn't take that long. It just takes longer to be able to explain it and go over everything. So anyway, I hope this helped. I'll see you on our next exercise. Bye.